In this part, we're going to see how to integrate deploying to Kubernetes cluster in our whole pipeline. So we have already done some steps for our CI/CD pipeline, and now we're just going to add our new deploy to Kubernetes stage into our existing pipeline. So there are a couple of things we need for that. So I'm back in the deploy on Kubernetes branch. So this is the part that we want to integrate into our existing pipeline. So I'm actually going to copy that, and I'm going to switch to our Jenkins jobs branch where we have been building the pipeline. So this is how our pipeline actually looks like. In this case, we're just using Jenkins file purely. We don't have an external Groovy script or Jenkins shared library, just to have all the code inside so it's transparent. But of course, as an end result, we can extract all of this to either shared library or external Groovy script. So first of all, we have the version incrementation, which gives us a new image version every time we run the pipeline. Then we have building the application part here, where target folder gets cleaned up or removed, and then new jar file gets created with a new version. Then we're building the Docker image, and this is our deploy stage here, which is currently empty. And then we have a stage where we commit the version increment into the Git repository. So I'm going to paste in my deployment to Kubernetes part here to give us a complete pipeline. So the image that we're building here needs to be deployed to Kubernetes cluster. Right now, we are just deploying an Nginx deployment without using configuration file. Of course, that is not going to be enough in our case, because we need to deploy the new image that we just pushed to the registry into our Kubernetes cluster. So first of all, I'm going to remove that line and let's start fresh. So there are a couple of things we need to do to make this happen. First of all, we need Kubernetes configuration for our application's deployment and service. So every time we want to deploy the new version of our application, we need to create a new deployment and new service. So for our application that we're building, Java Maven app, we're going to create a deployment YAML file and service.yaml file. So right here, I'm going to create a new folder. And let's call it Kubernetes. And let us create deployment.yaml and service.yaml files. So I'm going to paste in the very simple deployment file for our application. So basically, we have name and label everywhere. We are just calling it Java Maven app. And I also have the service, YAML contents, and let's just paste it in. Very simple. We have port 80 of the service and port 8080 of the application. Let's see. This is our application's port. So we have Kubernetes YAML files that we can now use in Jenkins file for deployment. Now, the second thing we need to do is set an image right here, right? Because we are generating a new image every time pipeline runs. The image name is actually dynamic. So we cannot just hard code the image name right here. We need to set it dynamically through environmental variable. So let's actually go ahead and do that step now. So I'm going to copy the repository name. And at the end, we're going to need the image name. So we're going to set it actually using an environmental variable image name. And this is the environmental variable name that we're setting in our Jenkins file. So we are going to substitute this value every time the pipeline runs. So always the newest image version gets set right here. And we have image pool policy defined, which basically always fetches a new image when the pod starts, no matter whether that specific version is existing locally in the Kubernetes cluster. And what we can also do, because we are repeating the name and labels of the application on a lot of different places and in service as well, we can also replace them with environmental variable, and we can actually call it app name and also set it from outside, so that if it changes, we don't have to change it in all different places, but just once. So let's actually replace it everywhere. And there you go. So we are going to need a new app name environmental variable in Jenkins file. So now we have the names of services, deployment, and pod and container, as well as selectors and labels defined as app name environmental variable. So we actually have to set this value outside. So just like image name environmental variable gets set here, we can actually define it somewhere in our Jenkins file. It can be right here at the beginning, or we're going to actually set it in our deployment block. So in the environment block, this is basically the same as setting environmental variables, but rather in its own block. So there are a lot of different ways of setting environmental variables inside Jenkins. You can do assignment directly like this inside the script, or you can use environment block inside the stage, as you see right here. Or if you want to set it for global usage, you can actually set it right here. We can also have environment block like this. So there are different ways of setting it. We're gonna set this one inside our deploy environment block. So app name, and we're gonna call it Java Maven app. Of course, if you have a business application, it's gonna have some more meaningful name, like it's a payment app or it's an online shop or whatever. Okay, so we have those two environmental variables defined here, and we have the syntax inside YAML files where we are setting them as $image name app name. So the question now is, how do we substitute these values right here, the image name and app name, from Jenkins file, right? How do we pass those values to the YAML files? Let's actually see the syntax for it. So first of all, we have our usual kubectl apply, right? And usually we have kubectl apply -f, and we pass in the file as a parameter, right? We pass in deployment YAML file or service YAML file or whatever. Right now we have a template file of Kubernetes YAML files. So before passing in the file, we need to substitute all the placeholders defined in those YAML files. So what we're going to do is use a command line tool called env substitute or environmental substitute. And environment substitute command is actually used to substitute any variables defined inside a file. In our case, it's a YAML file, and the syntax that this command expects is actually $ and the name of the environmental variable. So this should actually match. An environment substitute is a tool that we need to install explicitly inside Jenkins container. It is not available out of the box. So what does environment substitute command do? How does it work? We pass a file to env-subst command. This could be any file. In our case, we have Kubernetes deployment YAML. It is in the Kubernetes folder, so we are defining the relative path. So what this will do, basically, it will take that file, it will look for syntax of $ and name of the variable, and it will try to match that name of the variable to any environment variables defined in that context, right? So these are all basically environmental variables we're setting in the Linux in that context of execution, just like we would set them on a command line before executing a command. So it will find an image name environmental variable, and it will substitute this value right here with that environmental variable's value. And it will do the same for this one. It will try to find environmental variable called app name. So these two should match, obviously, and it will substitute right here. That's what env_subst actually does. And it will create a temporary file with the values set, and we're gonna pipe that temporary file and pass it as a parameter right here with this syntax. So basically, result of this will be then piped or passed on to the next command, kubectl apply, and will be passed in as a parameter at the end. So that means we're still gonna have our deployment YAML file. It is not gonna get changed actually, the original file. The new file or copy of that file will be created where the values are substituted, and we're taking that temporary file as a parameter here. So that's how it works. And we're gonna do the same for service YAML because it also has app name environmental variable. And we're gonna do the same right here. And then pass that service YAML with values set already to kubectl apply command. Now, as I said, env_subst is not available out of the box. We need to install it first inside our Jenkins container so that Jenkins can execute this command inside the pipeline. So let's go back to our command line. I'm gonna SSH into my droplet. Let's do docker execute, and let's enter as root user because we are installing something, so we need permissions. And apt-get install get text base. This is actually the package that includes environment substitute tool. And there you go, the tool got installed and it should contain env_subst. So let's execute it. There you go, we have the command available. It doesn't do anything, but it doesn't tell us the command not found. Okay, so we can leave the container now. Everything is installed. So basically we have created the Kubernetes configuration files with placeholders to dynamically replace the image name as well as the application name. And we are passing those values as environmental variables and substituting them using this environment substitute tool, and then applying them using kubectl apply command. Now there is one last thing that we need to do for this to work, and that is DockerHub registry secret. So the way this is going to work is we're creating a new image and pushing it to DockerHub repository, right? So when we execute this line right here, kubectl apply with the deployment YAML file, and we have set the new image name here and repository name of DockerHub, Kubernetes must be allowed to actually fetch that new image from the private repository. And because DockerHub private repository is secured, we need authentication with the registry from inside Kubernetes cluster. So basically, the credentials we're using here, the GitHub repository credentials, must also be available inside the Kubernetes cluster. And the way we do that is by creating a secret of a special type of Docker registry type with all the credentials, with username and password. And because it is a one-time event, we just need to create that secret once. We're not going to put it in the pipeline because the pipeline gets executed every time. We can actually create that from our local machine. So I am connected to EKS cluster. There you go, we have EKS. And from here, we can actually create that secret using kubectl command. And you don't want the commands and execution to be spread around. Of course, an option would be to have that command also in the pipeline and maybe check whether the secret exists already and only create it if it doesn't exist. That will be an option. In our case, I'm going to create it once in the Kubernetes cluster, because usually if you have multiple projects in a team, maybe microservice applications, they will all be hosted on the same repository. So that should be created once per namespace. So if you have multiple namespaces, obviously you will need to create the secret multiple times in each and every namespace, because you can't use a secret from another namespace. So again, based on your preferences, you can create the secret directly from here, because we already have kubectl available in the pipeline. Now, obviously, there are advantages for both methods. So for example, if you have multiple microservices that are all created in its own namespace, you can actually have that step inside the pipeline, because every namespace will need its own Docker registry secret, so you can integrate it in the pipeline. You can have an if statement where we check whether the secret exists already. If not, we create a new one. But if it's just going to happen once in the cluster, we can actually go ahead and do it from the command line using the kubectl command. So let's now create the secret for Docker registry. And the command for that is kubectl create secret. And this is going to be the secret type, which is Docker registry. And next we have the secret name. We're going to call it my registry key. And we have a couple of options that we need to set. First of all, we need to set the server. Where is this Docker registry located? In our case, it's a DockerHub, and the Docker server name of DockerHub is actually docker.io. If you're using Nexus for your Docker registry, then it's going to be the name of the URL of the Docker registry you created. On AWS ESR, this is going to be the repository URL that you can copy from the ECR. And the next parameter is going to be the Docker username. This is the username that you use to log into your repository. It's my username. And finally, we have Docker password. And that is, again, password that you use when you log into a repository. And with these three values, we can create a Docker registry type of secret. So let's see our secret. There you go, my registry key. And the type is Docker config JSON, as you see right here. And it is available now. So now that we have the secret, we need to make use of it in our deployment file. So inside the specification of our pod, we are gonna set image pool secrets. And very simply, this is gonna be just the name of the secret. We called it my registry key, and that's it. So basically, every time Kubernetes checks this configuration file, it sees, okay, I have a private registry and the image that I have to fetch from there, it will need the registry credentials. So it will take them from the secret in order to pull that image. And that's it. So we basically have everything ready in order to build our image and then deploy it using that new image version into the Kubernetes cluster. So let's commit everything to the repository, and then we're going to run the pipeline. So and git push. Everything looks fine. So we have everything configured in our Jenkins file. The cluster is empty. There are no pods running inside, no deployments or services. So now we can go to Jenkins and trigger the pipeline for Jenkins jobs branch. Right now, it's configured for a different branch. Let's actually change that and set it to Jenkins jobs. And it's going to scan and start building the pipeline. And there you go, you see that all the stages got executed successfully. We have deploy and commit version update at the end. So let's actually check the logs first. So we have a bunch of output for all the stages. We have our kubectl executions right here, and we have the feedback from cluster that deployment and service was created, and then commit back to the repository. So now if we do kubectl pod, you see that the Java Maven app container is running. And let's actually do scribe. And if we scroll to the container section, you see the image, and this is the build name of our Jenkins Shops pipeline. So the image name got dynamically replaced, as well as the deployment name, which is called Java Maven app, as well as the service, Java Maven app. So now we have more or less complete pipeline, which executes all the steps that you will encounter in real projects, that actually streamlines the application building and deployment to the first, let's say, development server, while incrementing the version of the application and the Docker image that we're building with every pipeline run.